Buenas tardes. Me llamo Tomás Stroka, architect. Gracias por esta oportunidad. El título es Indiana Limestone in Classical Buildings Today. Bedford or Salem Limestone, commonly known as Indiana Limestone, has been used in building construction for 2 centuries in the United States. A sedimentary stone, it is a natural calcite-cemented stone from fossilized skeletal material in a shallow seabed formed 300 million years ago. This paper will discuss the material properties of Indiana limestone and its use in classical architecture today. Specific projects by Duncan Stroik, architect, will illustrate how to employ this stone in creative ways. Indiana limestone is quarried in southern Indiana, where there is a natural outcrop of the stone. Across this vast area of ancient seabed, shell-protected organisms were broken and ground up, then redeposited by the action of water currents. These particles were compacted and cemented by crystals and saturated solution. Countless layers built up over time and became compressed and formed this sedimentary rock. One can observe fossils embedded in the stone. Indiana limestone is a free stone, which means it has no pronounced cleavage planes, but instead uniformity of composition and texture. It can be machined in any direction without danger of splitting, which gives it tremendous advantage as a building stone. Different colors of stone are quarried. Buff, which is ordinarily found above gray. Buff is colored by the action of groundwater moving down through the organic material within the stone, changing it to light, tan, or cream. The gray stone is at a depth not affected by the groundwater. The gray color can vary from a light silver gray to shades of bluish gray. Architects can specify buff, gray, or variegated, which would include blocks that have both colors in one piece. Specifying variegated stone gives the fabricator much greater flexibility in selection for the blocks harvested from the quarry. And there is more variegated material available, which means a lower price than buff. The natural deposits of the stone are large enough to supply another 500 years of building construction based on present extraction. This limestone can be used as cladding, which is integrated into masonry cavity wall construction. The stone can be used as large cubic pieces or as a load-bearing element. The compressive strength of Indiana limestone is 4,000 psi minimum, roughly the capacity of unreinforced concrete. Because it is a natural product, its physical properties will vary. It's resilient to weathering and has a high internal elasticity, which helps in adapting to extreme temperature changes in our buildings. The size and proportion of limestone pieces contribute to the nobility of the architecture and make a positive impact on the building's long-term durability. One project by Stroik employs Indiana limestone at the Chapel of the Holy Cross in Tampa, Florida, which was dedicated in 2018. This chapel stands at the heart of an all-boys high school, with rows of palm trees celebrating the main axis. The design looks to historic precedent in Renaissance proportions and in the work of Andrea Palladio and in Renaissance examples around Italy. The brick and limestone veneer reflect the color palette of the existing high school campus. The chapel walls have already withstood 4 hurricanes in the last 6 years, including, most recently, Hurricane Milton. To unify a building's elevation design, a classical architect balances vertical punctuations with horizontal bands or string courses, so that formal geometry and symmetry are expressed. At Jesuit High School in Tampa, this chapel is the tallest building and marks its hierarchy with a tetra-style portico on a symmetrical facade. The details are all carved in Indiana limestone, except the statuary is Carrara marble. The facade is articulated with a Doric portico composed of freestanding Indiana limestone columns, 24 feet high, 3 feet in diameter, and stacked in 3 drums. They frame the front doors, give protective cover from the sun and rain, and give dignity to the facade. The Doric order was selected because the Jesuit campus is educating young men, and this order has been used on temples since antiquity. Vitruvius proposed that the Doric column exhibits male proportions, strength, and grace, and that its simplicity of ornament is appropriate for certain temples. Indiana limestone is an absorptive stone. Pieces placed in direct contact with paving or perimeter grade will exhibit more wear and tear than granite or dolomitic limestones. Indiana limestone is a medium density stone and has consistent properties for carving. It's the perfect material for pieces such as coats of arms, bracket scrolls, capitals, and inscriptions. Over the front entrance door is the aspiration Ave Crux Spes Unica, and a symbol of the Society of Jesus, the IHS, in a large coat of arms escutcheon with laurel leaf carving and a cherub. Each drum is pinned together with stainless steel pins. At the top of the column, we anchor a steel plate connection to portico beams. The limestone entablature is proportioned according to the molding profile suggested by Andrea Palladio in his 4 books of architecture. Doric columns are 2 modules in diameter, a total of 60 minutes. The entablature height is 1/4 the height of the column. So here at the Chapel of the Holy Cross, the entablature measures 6 feet high, 1.8 meters. The cornice is 1 1/6 module and divided into moldings such as the cavetto, the echinus, the corona, and the cyma. The soffit, which faces down and projects out, covers the triglyphs. These cornice pieces sit extra deep and rest not only on the stone frieze below, but on the steel beams. An anchor engineer designed stainless steel pins to secure the pieces of limestone to one another. Normally, the cubic blocks of Indiana limestone from the quarry measure 4 feet by 4 feet by 8 feet. Some fabricators prefer larger pieces because there can be less waste and the total preparation time for the pieces on it is reduced. At the same time, we as architects believe large pieces of stone are aesthetically positive for the building and contribute to its durability. Cornerstones can be crafted in Indiana limestone. The inscription can be painted with lithographic paint to make it more legible, or it can be left natural. Another use of Indiana limestone is for horizontal string courses and for jack arch lintels and keystones. In Tampa, the limestone string course wraps the tall brick volume of the chapel and serves as a spring point for the arcuated windows and the niches at the front facade. The string course strengthens the geometric ordering of each wall elevation, dividing it into smaller components that relate to the whole. The Chapel of the Holy Cross stands proudly as a beacon of faith in the center of a school campus, and the specification of Indiana limestone helps to make it more durable and more ornamented. At Christ Chapel in Michigan, Duncan Stroik designed more freestanding Doric columns. They support, in this instance, a masonry dome spanning 32 feet, or 9.75 meters. Each column drum here weighs 6,000 pounds, for a total of a 26,000-pound limestone column. On top of the Doric columns rests a curved limestone entablature, the denticulated Doric. Each curved piece rests on mortar joints at the top of column. The brick dome is an unreinforced masonry dome and works naturally in compression with a steel tension ring. The main entrance doors are crowned with a curved pediment and carved brackets in Indiana limestone. Indiana limestone is especially consistent in grain for these very detailed carved pieces. At the side elevation, Doric pilasters in brick are articulated with limestone bases and capitals. One design detail is the kissing Torres of adjacent Doric bases, which Stroka utilized from a Palladian precedent example. At the peak of the 32-foot windows are limestone keystones supported by the brick arch to each side. Exterior limestone cladding, whether large cubic pieces or small veneer pieces, can be accommodated by the structure of the building. In a non-seismic zone, unless it is completely supported from below on a slab or stem wall, the limestone pieces can be supported in compression by the masonry veneer. But they also may need to be anchored or pinned to the structural backup wall for wind load resistance. The stainless steel attachments can be variously sized and are detailed by an anchoring engineer. The interior limestone columns at Christ Chapel are structural. They support the live load of the side gallery seating as well as the roof structure of the chapel above. Finally today, at Capstone Classical Academy in Fargo, North Dakota, Stroka specifies Indiana limestone again. This project is currently under construction. We require samples, shop drawings, mock-ups, and anchor engineering. The pieces of Indiana limestone are variegated in color and are cut to a smooth finish. Every window opening in the project has either a limestone keystone or a limestone jack arch. These lintels are very effective at transferring the weight of veneer brick above to the adjacent jamb. Indiana limestone can be as stiff as steel. The door surround for the entrances of capstone are proportioned to be no thinner than 1/6 the width of the surround to the width of the span opening, recommended by Palladio. The architrave goes around the door and must be as thick as the jambs or pilasters, which, I have said, must not be made less than 1/6 of the clear breadth of the door, nor more than 1/5. That's a quotation. Limestone that is in contact with the ground or with cementitious concrete should be protected with damp proofing at concealed or buried surfaces. The mortar that is to be used should be type N, ASTM C270, with low alkali cement, and the water mixed in should be clean and potable. The protection of Indiana limestone during construction is of utmost importance. The top of walls should be covered to prevent moisture entry. Sills and ledges should be protected from mortar droppings as the work progresses. One can see strap marks from crating and shipping that remain visible on the surface of the stone at project completion. However, this usually clears up with exposure to rain and ultraviolet sun rays over a few seasons. Today, we have discussed the material properties of Indiana limestone and its use in classical architecture today. It has proved itself a worthy building material in the past and has a promising future across the United States and beyond. Thank you for your interest and best wishes for each of you and your work.